All right. Hi, everybody. Thank you for joining us today. And thank you to all the panelists for joining in this discussion. I'm Elizabeth Reynolds. I'm the program director for Starburst Aerospace. We are a global organization that supports innovation broadly through consulting at both the corporate and government level and doing a lot to support innovation on the ground through acceleration and funding for founders. Before we kick off the discussion, I'm going to invite all of my fellow panelists here to give a brief intro to themselves and their companies, and then we'll go from there.
Thank you, Elizabeth. I'm Susan Ying from AMPAIRE, and I've worked in the aerospace industry for the last 4 decades, and so very happy to be here. Thank you for having me here. And so in aerospace industry, so far, we've been sort of a generator of a lot of the carbon emission. And while AMPAIRE is a startup that started in 2016, and so we focus on sustainable aviation. Namely, we're trying to build airplanes for the sustainable future, which would be flying quiet and will fly clean, and also it will be a lot more affordable. Really happy to be here. And this is a video that you're seeing that our first prototype that has flown against the background in Hawaii. And so since we started the company in 2016, this airplane first flew in 2019, and then in 2020 we went to Hawaii. 2021 we went to UK to actually did the market survey type of flight as an experimental aircraft. And so far the longest that we have flown was 418 nautical miles. So with a hybrid electric airplane, you can do that already today. And this is a 6-seat aircraft. Thank you. You got one.
So I'm Robbie Robertson. I'm a CEO and co-founder at Sedaro Technologies. We're on the space side of things, so kind of offering that perspective on the discussion. We build a cloud-native platform for simulation of spacecraft and constellations, digital twins as well of spacecraft and constellations. So our role in the industry is basically to support all of these teams that are building incredible, complicated, systems in space. And one of the big applications of that technology is obviously monitoring Earth from that unique perspective and providing a lot of the data that informs our understanding of the climate change that's happening and its kind of downstream effects, like in wildfires and events like that, and empowers us to respond more effectively to those things. So we're using this software tool and trying to provide it to organizations that are building complicated spacecraft and constellations so that they can basically build more complicated things and operate them very effectively. So thank you.
Good afternoon. I'm Anita Sengupta. I'm CEO and founder of Hydroplane Limited, and I'm also a professor at USC in the Astronautical Engineering Department. I'm here representing my company, though, and so we're also focused on the sustainable aviation sector, specifically hydrogen-powered aviation. We're not developing an aircraft. We're developing a hydrogen fuel cell power plant, but for aviation, starting with a smaller aircraft, but also hoping to support things like urban air mobility, which is eVTOL, as well as larger ground-based vehicles and marine vehicles. We're funded by the Air Force, primarily in private investment, and we got started during the pandemic, actually. So I'm also a very active pilot in Southern California. I'm a pilot with the Civil Air Patrol, so my primary hobby is flying, and I have a terrible carbon footprint. So this is my way of addressing it. And hydrogen is definitely afoot, the movement, certainly in California, so from an automotive perspective and hopefully as well from an aviation perspective. And I would say globally, hydrogen is now being looked at as a really viable energy carrier, which is more sustainable than obviously hydrocarbons.
Wonderful. Thank you all. And obviously we're on this panel talking about aerospace and climate change. I think probably for all of us, those things are pretty intrinsically tied, but that may not be the case for everyone in the audience. So I'd love to hear from you guys. What are your thoughts? How do you think climate change is affecting the aerospace industry in general, and what are our roles and responsibilities in creating these solutions to help mitigate it?
Climate change, is happening, and the thing is that aerospace is one of the guilty ones who has generated all that emission. In fact, I think it was just a couple years ago that in Norway, they talk about flugskam, which is shame, flying shame. So shame on you, that's generating all this carbon, right, for flying. And then in fact, even today, I think in a few of the countries, they restrict flying domestically. So if you fly anywhere domestic, you got to take the train or other means of transportation. And this is largely because of pre-pandemic aerospace industry, or I'm talking about the aerospace aviation commercial flights, are generating like 900 million to 1 billion tons of carbon dioxide per year. And if you use that projection going to 2050, that's going to make us one of the largest generators of carbon. And so we've got to do something. And so the good thing is that it's impacted aviation such that we're going through a revolution right now. So as you all know that we started flying only 100 years ago with the Wright brothers first took flight in Kitty Hawk. But since then, there's one other revolution, which is the revolution for jets, invention of jets. And that's about 70-some years ago. And since then, we could fly much faster or generating a lot more carbon faster or flying higher, right? So in order to reverse that, we got to take a different approach to the propulsion. And so it's very exciting now that, from the ground vehicles converting to electric, that's created this economy of scale. Because if it's just airplanes trying to fly electric, back in 1970s, people tried. But the thing is that the development is slow, and also you don't have the kind of economy of scale, which lower the cost. Because in the last decade, the cost of batteries have dropped like 85%. Thanks to Elon Musk and many of the entrepreneurs in the electric vehicles. So it's very exciting now. We can, jump on this bandwagon and also work in the aerospace industry to embrace the electric aviation and other type of propulsion.
Sure. So I think, in a sense, aerospace is its own worst enemy because oftentimes aerospace has been the domain of large multinational corporations like the Boeings and the Airbuses of the world who don't have to innovate because they already have a product that works well for them. So that's where I think aerospace has been kind of stalled because of that. But I think just as we've seen with Elon Musk and Tesla, it requires the startup mindset to come in and actually to revolutionize these sectors. And what's so nice about aerospace, it's a very difficult environment to design for. So if you can design something to be lightweight and super efficient, it actually carries over into the rest of the economic sectors and verticals. And so when you look at hydrogen sector specifically, right now hydrogen has the problem of not having the infrastructure. So California is the only place in the United States where you can have a hydrogen powered car. My company has all Toyota Mirai's that we drive around, and so it's great because we live in LA, so we're able to recharge our vehicles or refuel our vehicles. So when you have use cases like aerospace, which requires for regional travel, things like hydrogen fuel cell technologies to be truly emission-free, you get the synergy of people supporting the infrastructure development, people supporting the production of green hydrogen, which then supports more green energy production. So it's actually synergistic in that way. So I see aerospace as being a great driving function to get more sectors of our society to be emission-free.
My field, space, it's a very different, I think, position in this problem than aviation. There is pollution, that's generated by launches and by the reentry of spacecraft. It's not a very well understood problem, as I understand it, although it's not my specific area of expertise. But in the end, it's relatively small as the consensus compared to, obviously, what's produced by aviation and other industries. So the role of space is primarily to help understand the problem. The Earth is a complicated, system, a physical system, and all of the models that are used to understand climate change and understand its downstream effects, as I mentioned earlier, are informed by measurements that are made from space. So there are exciting startups, actually, in the industry right now who are measuring greenhouse gases. One like a GHGSat, I believe is what it's called. And they're getting commercial traction by providing valuable data to industries totally not aligned with climate change, but also collecting data that can inform the science. So I think that's companies like that, new space companies are kind of an exciting new thing that can contribute in a big way to addressing climate change.
Absolutely. And the next panel will dive into a lot more of the specifics around how satellite data informs what we know and how we address climate change. We're even starting to hear a lot more in recent years about reusability in space for reusable satellites, obviously reusable rockets. And I think that the framework around climate change is really affecting how we think about everything as we look at the space economy as well, and the limited resources we will have to continue to expand there. But as mentioned, there's a lot happening with some of the new emerging technologies and companies. There's just an overwhelming entrepreneurial boom happening in aerospace today. So how do you as private companies, as relatively young private companies, think about your impact as you're looking at climate change, which is such a large global systemic problem?
Okay, so I'll first start with all the very exciting development right now in the sustainable aerospace. So there's actually a couple of camps, I should say. And so first introduction is, you probably have heard just now the word eVTOL. Not everybody has heard that, which is electric vertical takeoff and landing. So those if you call those airplanes, are very exciting that, if you're sitting in the traffic jam, which is just about every day now, to go from one side of LA to another one, you can take these eVTOLs from one side to another, avoiding all the, ground traffic. So that's one area, and so we call that area urban air mobility. And then another area we call regional air mobility, namely, anywhere, say, above 50 miles to 500 miles or 1,000 miles. You can have the regional aviation, and I believe that's what just now we were talking about. So regional and urban, then the overall development in this area, in the advanced sustainable aviation, is advanced air mobility. And so usually these urban air mobility, so currently there's like more than 300 projects going on with all these new propulsion kind of aviation devices. And so in the urban air mobility, you usually have these 2-seat or so eVTOLs that can take you from A to B, which is within 50 miles. In fact, the first one that's to be certified, that's from China, it's called the Ying. They're certified only for 19 nautical miles, which is about 30 miles, which is not very far from A to B. So that's the urban air mobility, and they require to have something like vertiports. So just imagine, like in Jetsons, right? You go take off from one vertiport to go to another part. So it's like just around the street corner type of thing. So that's, so it's kind of like a flying taxi for that kind of services. While as for regional advanced mobility is such that you can fly from, your local airport, because in the United States, there's, I think 70% of the people live within 30 minutes to a local airport. So it's, it's very accessible. In fact, currently in the commercial aviation, we only use about less than 500 airports of the country, while more than 10,000 airports are here in the United States. And more than 5,000 are publicly maintained, namely the resources come from our tax dollars. And so advanced regional air mobility allows us to tap into all these resources and just basically use these regional airports a lot more affordably. I mean, before you could use those airports too, but for those kind of short-haul airplanes or general aviation airplanes, they're a lot more expensive. So the affordability is something that we get from the electrification from these new sustainable aircraft. Just to give you a real quick comparison, there's already a 2-seat electric airplane that's been certified, that's now rolled out for training. Now, how many of you are pilots? I know you are, and have flown a 2-seat Cessna aircraft, for example? All right, so let me tell you, it's very expensive to go out and try to rent an airplane, and plus the CFI, the instructor's costs. Each hour is going to cost you at least $150 just to learn how to fly, or even on a joyride. It's minimum at least $100 an hour. Now these electric airplanes, 2-seater, the one that just rolled out, Each hour, the energy, electricity, costs you €3, or say less than $5. So it's orders of magnitude difference. So this affordability that it brings really allows us to have very efficient regional air flight. And so that's really, really exciting. And so right now we have a dozen or so electric airplane companies that are in the competitive landscape. And of course, just now we heard about the hydrogen fuel cell. So hydrogen comes in, and in fact, right now it's also in the electric vehicles selections. In fact, there's a really good video that just came out by Miles O'Brien, I think just recently, that you can see about the Toyota service using the hydrogen. The thing is, a hydrogen fuel cell is also electric, so it's like a hybrid electric hydrogen aircraft. It's very exciting, but the problem with all these is that you have to talk about energy, and it's the source of the energy. I mean, whether its source is hydrogen or whatever, and hydrogen in its natural state, it doesn't, it doesn't exist. Right? So you have to get the hydrogen into some form that you can use. And that process, you talk about the gray hydrogen or green hydrogen. And so you cannot generate more hydrogen without generating more carbon at this point. So that's one of the challenges. And so you're talking about the generation of the fuel, and then the distribution, and then management, because if you're at the airport, you have to use all that resources. You have to manage it such that, it's, for example, if you use the electricity that's generated, you don't black out the whole airport or something like that. So that's, there are a lot of challenges with the ecosystem that supports the whole sustainable aviation. I don't want to occupy this word.
So I mentioned, we're a tool for people building these types of capabilities that are related to climate change. I think as far as how we run the business as it relates to climate change, and what's driven by that is in the applications that we demonstrate for customers. Our main demo, which I think Elizabeth has seen, is a wildfire infrared imaging constellation that will provide active information about active wildfires to inform those that are fighting the wildfires. So somewhat related. So I think it drives the capability we provide. It's more of a market driver for our customers than we're providing with our technology to make them able to do it better, do it more efficiently. But yeah, definitely curious. I think it's something that obviously drives your businesses, and curious, what it's fundamental. I guess it's where it came from, right?
Yeah, and obviously we're focused on hydrogen and hydrogen fuel cell technology. And for a point of reference, I drive a Toyota Mirai. Now it's actually cheaper for me to fuel my Toyota Mirai with $13 per kilogram than it is to fuel it with gasoline, or to fuel my gasoline-powered car with gasoline. So the price of hydrogen, although it is quite high, currently it's still cheaper because of the efficiency you get in the electrochemical reaction using a fuel cell versus internal combustion. It's still cheaper now at the high price of hydrogen to drive a hydrogen-powered car. And so the projection for the decrease in the cost of green hydrogen is that it will drop down to $4 a kilogram. So there's actually an economic argument for hydrogen being the fuel of choice for both ground-based vehicles and obviously for aviation, because that's all that's going to support long-range applications. What's so nice is that when you go to your local hydrogen fueling station now, you can look up online to see how much of that hydrogen is actually produced as green hydrogen. In many cases, it's almost 100% now. So what happens is you have green electricity that's produced by solar or by wind, that then is fed into an electrolyzer, and then that allows you to produce hydrogen. So the majority of the hydrogen which is available, if you decide to go buy either a Hyundai Nexo, not to advertise them, a Toyota Mirai, or a Honda Clarity, will actually be completely green hydrogen. And there's literally like a button on the dash of your car, which is H2O, you push it and water comes out the back of the car. So ultimately, the technology that we're developing is going to be more efficient hydrogen fuel cell technology, which is catering to the aviation power profile, which is quite different than the automotive power profile, right? Because you accelerate in a car and then you cruise at a really low level. In aviation, you're essentially cruising at 70% of your peak power. And so if we can come up with a more efficient fuel cell, a more cost-effective fuel cell that can be filter across to many markets. We're starting with aviation because we think that's the most difficult and the most important problem to solve, but automatically couples to marine, automatically couples to buses and to trucks, And also, this is something that Europe does a really good job with, is they have a lot of excess capacity from their wind farm. And so what they want to do is take their excess electrical capacity from the wind farm, put it into an electrolyzer, convert that into hydrogen, which then can be used as a storage means instead of having batteries, which also has a pretty bad carbon footprint from a rare mineral mining perspective. So not to be the hydrogen champion, but it really is a good solution for a large range of energy problems that we're facing as a society. And of course, hydrogen is used as, hydrogen and oxygen is used as rocket fuel. So it also has a good application to the space side of things.
Absolutely, and I love what you said about the fact that you're tackling this because it is the more difficult problem to tackle today. And I think that's one of the advantages that you have as a private business, and you're a lot more nimble and able to make some of these changes quickly and decide to tackle those problems that are a little more challenging and have a little bit longer timeline. I'd like to build a little off as well this discussion of kind of how we approach this on the hardware and software side. Obviously, there are innovations happening every day, and people who are approaching both points that have been kind of a little sticky or that can be made more efficient from a lot of different angles. How do you guys view having the most cutting edge technology for both a hardware perspective, a tech stack perspective? How important is that to you as you look at your market entry and being competitive, and how does that impact your relationships with some bigger corporate partners?
Well, I think it's essential. The advantage that we have as a smaller, newer company is that we can build off of a new foundation, technology companies, even us as a software developer, a relatively agile entity, indefinitely. It's a lot easier to, start over with a new element of your software stack for your web application than it is to, build a new manufacturing facility for hydrogen fuel cells and tweak that tech in a core way. But it's still a huge advantage just to be able to build that foundation, make really careful decisions early on that will support your business as it grows and give you an important advantage over your competitors. For us, that's building in the most modern possible software stack, which right now is web applications and cloud native applications. So leverage, what Facebook has built and open sourced to build a simulation, interface, for example. So I think it's really, really important.
Let's see. I think I would say certainly in order to be able to survive, you have to have a product offering which is much better than what's already out there, or you have to solve a challenge that hasn't been solved yet. Also, you have to understand who your customer is. And so, right, for us, like, our customer is not like people who own small cars, because there's already a technology for that. So our customer is the more difficult customer, which is, high durability, long duration, long endurance aviation applications. So I think for us, it was important to actually design a system around that customer and what they need, and to bring a product to the market that just doesn't exist yet. So we were trying to solve this problem that hadn't been solved yet, but in other cases you just have something which is either more cost efficient or more energy efficient, so that it ends up being more cost efficient. So it's kind of like the systems engineering approach to designing your product.
I just want to add that today, in offering this kind of advanced system, complex advanced systems, like what we're building is actually energy optimized electric propulsion system. You can't just sell the hardware without the software. I mean, in fact, the whole thing that makes it optimized has to be software working hand in hand with the hardware. And in this way, you can get the whole optimal system. In fact, in the academia, I think just before I left Boeing, I worked in Boeing for 20 years. Just before we left, we were actually helping to start another curriculum, which is cyber physical systems. Because especially, you talk about embedded software or whatever the software that's making the control. Because now, the control is all by software. And so, just how you put everything together, how you optimize the whole system is very important. And especially from a startup's perspective, because we don't have all the baggage of how things were developed first using the hardware and the control and all that. You could think differently using the software and taking advantage of all these new technologies and innovate. And yeah.
Absolutely. Something else I wanted to touch on is we are talking about kind of the breadth and scope of the problem of climate change is the role that government plays in that. Obviously, a lot of aerospace research and development is funded by government grants. How much impact does the government have on the technologies that are being developed today? And we can talk about this both from a grant perspective and a legislation perspective.
Yeah, I think the easiest analog for me to speak to, given what we do, is not necessarily directly climate change, but is a good example of how that the perspective on sustainability has gotten to places that it hasn't historically because of our what we've seen with climate change and what our kind of society and our government emphasizes now. And the problem is space junk, orbital debris. I don't think I would have predicted 10 years ago that the Space Force would be creating kind of flagship programs around cleaning up orbital debris, and they're doing that now, and giving a lot of money to startups like us to create the technology required to do that. It's a very complicated problem. They could be, spending it on creating the next, missile system or something, and instead they've invested a significant amount of money in solving this problem, and they talk about it a lot. So, I think that's for the government to see something that's a further off goal. I think that's the role they can play. Just like NASA focuses no longer on anything basically that industry can't provide, they try and focus on the most challenging problems, like sending James Webb Space Telescope out to L3 and this massively complicated one-off thing. But I think the fact that the government should be there to invest in creating, solving deep tech problems, creating solutions to those, because it's hard for startup companies to utilize private equity for that in some cases, because the commercialization isn't too close. So I think climate change being a very long-term problem, there's a big role for the government to play in making investments there.
In addition to investment, I think government can play really a central role in the policy making to drive the change. So for example, just now I mentioned like in some countries, they already forbid flying domestically in country. But other countries, they also have set carbon offset. Like whenever you buy an airline ticket or something, and the airlines get some carbon offset and things like that. And recently, there's even more incentive in terms of some of the policies in terms of buying the SAF fuel for flying, because we know SAF is a sustainable aviation fuel, for example, and it could be biofuel or other synthetic kind of fuel. It's kind of, in driving these changes, it's kind of like a chicken and egg kind of thing, usually. So for example, the Boeing company has flown SAF with the Boeing company with the Virgin Atlantic sort of flight using SAF fuel. However, this was in 2008, and now it's 2022. You can only count by one hand of how many airports these SAF fuel are available. And that's mainly because, they don't get a whole lot of incentives in using the SAF. Yes, it will help to drive the climate change and everything, but the thing is that to combat climate change. But the thing is that the SAF is more expensive than usual Jet A. And it's not available because, there's only very few companies out there making the SAF. And that's why it's only available at 5 airports around the world, 2 in Norway, 1 in Sweden, 1 in Australia, 1 in LA here. We were talking about the SAF fuel that's consistent that you can get like in every flight. And so, in fact, I found one of the companies that was supposed to sell SAF, and they just were going out of business and decided to change their business to making cosmetics. So, because it's a lot easier for them to make a profit. And so, so the government should be able to help set some kind of policies to drive these changes, and similarly with electric or hydrogen, because it's once again like a chicken and egg kind of thing, talking about infrastructure, because the airport's not going to go out and spend the money to work on the infrastructure unless there's the definite requirements, and there's no requirements from the airline because they say, well, there's no infrastructure there. How am I going to fly these electric or hybrid electric or hydrogen airplane? because it's not available. So the government can go in there and break this chicken and egg kind of cycle and help to drive the change towards the positive climate change. And so I think that's one role. Another thing is that in other countries, for example, in European Union, there's aviation, clean aviation. Prior to this is Clean Sky, where they put billion of euros for investment in driving the change. For example, helping out these airplane and airplane systems company to develop these new technologies. And similarly, in UK, they have a council, the Flight Zero Council, that established so that they can help the government can invest money in the strategic technology areas to help drive these changes by developing the right technologies for it.
Yes, I agree with all the panelists. And anytime transportation infrastructure is involved, government investment is absolutely essential. It's not going to happen without it, just because you may not even own the land, right, in order to be able to put some of these infrastructure assets in place. That being said, I am a little bit conflicted on this because I don't think it makes sense for the government to be the driver behind the change. So an example of that would be if you were a locality and you were making a choice between investing in charging infrastructure versus hydrogen infrastructure, and you pick one versus the other, but you're not really making an informed choice. So I really think that government should be doing the ROI type of thing, which is providing grants and contracts to invest in new technologies that allows the private sector to come in and come up with these great solutions. And this is actually a piece of advice which someone gave me a long time ago, which I think is really powerful because I've started to use it in my own life, is that people have different interests when it comes to energy, when it comes to transportation, when it comes to infrastructure. It's also a highly politicized environment. So when you're involving the government, it's going to keep on changing every time there's a new change in power, whoever's in the state government, at the capital, or at the federal government. So you have to find ways that you can have intersectionality, is what it's called, where you can all benefit from a change. And so in the context of what we did by getting Air Force funding and getting Air Force contracts, one of those areas would be reducing your dependence on foreign oil, right? As a country, we benefit from not having to rely on hydrocarbons. We benefit from going with green energy production, which also couples to charging of batteries, which also couples to electrolyzer to produce hydrogen. So if you can find ways to find disparate people who have different issues and come up with a solution which solves a bunch of issues, you can actually be very successful as an entrepreneur and as somebody who's in kind of the tech sector. But I think, though, that providing government funding through programs like, NASA, DOE, DOD with STTR, SBIR really is the innovation, the change innovation for this country. So it's a great thing that they do it. And we're certainly very thankful for our contracts.
So talking about intersectionality and the opportunity for all of these new solutions to come to market, there are a lot of different approaches being taken to new power sources, and we're seeing larger finished products roll out in many different formats, different synthetic fuels, purely electric, hybrid. Looking at the space sector, we're actually seeing fusion happen in real time, which is really exciting. But how do you guys think we're going to see this roll out in the market, and is there going to be kind of one winner as we look at these new technology options?
Well, I think, I hope not. I would hope that there would be multiple winners, and I'll give you the analogy in the context of ground transport. We were just up at the H2 Village in Sacramento a couple of weeks ago, where everybody in the hydrogen space was showcasing what they were doing. And what you're seeing is that in the context of ground-based vehicles, for cars, small cars, compact cars, batteries are great. For trucks, it's useless. You have to go with fuel cells. For planes, going large distances, obviously, you also have to go with either combustion of hydrogen or fuel cells. So there has to be a multiple solution because there's multiple product lines, there's multiple use cases, and that's why I really think the market has to drive those decisions, because it can't just be a government entity driving those decisions. But I think there should be a large number of solutions, and eventually the one which is most efficient, the one which is most cost effective to support a particular portion of a market will come out as a winner. But I would hate to only see batteries or only to see hydrogen. I want to see everything because I think that's the right solution for the planet.
Yeah, I mean, there are a number of, I guess, different relevant technology areas in space where there's competition, there's alternate approaches. My hope would be that there aren't, big, clear winners, because historically, I think in general, outside of our market, one winner doesn't lead to, the most efficient solution over time, and it slows down innovation. So, my hope is that SpaceX isn't launching all of everything going forward, because at some point they'll become less innovative. It hasn't happened yet, but so it's good to see that there's a lot of competition there, and that's a good example of where the competition and the innate financial drivers of them dominating that industry or anyone else also correspond to those vehicles causing less pollution and being more environmentally friendly, because it's all about reusing them instead of letting them burn up in the atmosphere or land in the ocean. And the engines are just dialed in as much as possible to keep them efficient, to improve that efficiency, and that also results in less emissions. So.
In general, I agree with the fellow panelists, but I want to add another dimension to this, and that is time. Because as we're developing the technology and so on, time is going on, and then you still have the emission keeps on building up, right? So there's something we already can do now, which is by hybrid electric, because one of the things about the aerospace company that is so different from the automotive and other industry is that safety is critical, and so we're highly regulated from safety perspective. So everything that flies has to be certified in the US by FAA, in the European Union by the EASA, and other CAAs by other countries, and so on. So unless you're certified, you cannot fly the vehicle for commercial hire. I mean, you can fly it as experimental, but you still have to get experimental license and so on. So in order to do this, they really scrutinize your design. And so the fastest way of solving this problem right now or in the near future is through hybrid electric. We know it works. We know the electric works because the first two seater is already certified. We know the combustion part works with SAF and so on, so you could still make an impact of 100% emission-free by a hybrid electric airplane. And we should do that. That's a near-term solution.
Yeah, I agree. We still have a long road ahead of us, and I think looking around today, we can all see a future in the automotive industry where it is purely electric or at least zero emission. I think the big question is: Are we going to see that in aerospace? Are we going to have that Tesla moment in aviation? Is the industry in its entirety, is it possible to get to an emission-free point? And what sort of new technologies do we need? What sort of infrastructure and support do we need for that to really happen?
Yeah, we definitely need a lot of infrastructure. But I would say that it's actually easier to do the infrastructure for aviation than it is for automotive, because for automotive, you have to have a gas station on every street corner. For aviation, you just need to roll it out for a few key routes, which have the highest carbon output. So I actually think it's not a difficult problem to solve. I think it's just a problem where everybody has to want to solve it. And it does take money, but it's also not infinite resources. And if there's a business case, an economic argument for it, because literally your operational cost is significantly reduced, every single end user and operator will also want to shift to that technology. So it is a chicken and the egg in the sense that the infrastructure is not there. But if you gave an airline operator the ability to have significantly lower operating costs, they were absolutely going to take you up on that technology. And I think the only thing that's really prevented it from happening in aerospace is because the big players, which is the Boeings and the Airbuses of the world, have chosen not to innovate this area because they didn't have to. So I do think it can happen. It should happen. I don't think there's anything so difficult about electric propulsion power plants that makes them difficult to certify. They're actually more safe. They're more reliable. They have fewer moving parts. They operate at lower temperatures. So most of the failure modes that you would see with an internal combustion engine, turbine or piston driven, don't even exist for electrified aircraft. So I actually don't think that's a tall tent pole. I think the tall tent pole is the absence of the infrastructure at key airports, and the technologies are en route. You're not going to start off, obviously, with jet aircraft. Like even for fuel cell technology, the electrolyte doesn't exist right now. It has to be a high temperature PEM. We only have low temperature PEMs at this point. But even that is, a 5-year development cycle even to get you to a high temperature PEM. Yes, you have to go through the certification process, but the certification process for a brand new airframe, which all the eVTOL aircraft have been going through for the past 4 years, the FAA has actually ramped up pretty quickly on that. So to go with an existing fixed wing aircraft, it's actually relatively simple in comparison.
What's a PEM?
Proton exchange membrane.
Proton exchange membrane, okay.
Well, it's not that simple with certification. It's yes, if we do the retrofit for the existing airplane, not so. But even with hydrogen, you're saying that Boeing and Airbus are not really looking. They are. The thing is that with hydrogen, there's two ways of doing it. One is through the fuel cell, as mentioned here. But for the very large airplane, you're going to have to, you have another option, which is direct hydrogen combustion. For that, you have to put the cryogenic use, because hydrogen in its natural state is 3,000 times volume of the fuel, the Jet A fuel. So in order to squeeze all that volume down to you, so you can fit into an airplane and yet still carry 100 or 200 or 300 passengers, that's a huge challenge. And who would like to sit next to a cryogenic fuel tank of hydrogen? And just a few days ago, there was a news article from NASA that they found some leak of the hydrogen fuel tank. And so these are the things that, for space launch, you have a limited number of launch per year, but for these airplanes throughout their lifetime, even per day, you have hundreds and thousands of takeoffs and landings, and every takeoff and landing has to be successful, and the level of safety and so on is a lot higher. It's really scrutinized. And so in terms of certification, another challenge is that currently these regulations and standards to evaluate for the safety do not exist. So there's gaps of those. In order for those to happen, you have to have the committees come together and really draft those standards agreed by all the industry and so on. And that takes time. And that's why those eVTOLs, they've been screaming for already the past how many years, and it's still, there's nobody that's certified yet. And I think EHang is the first one that's going to be certified. But even that is still to come yet. So certification is a big challenge. Infrastructure is a big one. And infrastructure in terms of generating, for example, the fuel itself, that's another big problem. For hydrogen, right now, the whole world's hydrogen generation will emit 2% of the world's carbon. So basically, it's pretty much the same as the whole airline industry generating for flying the airplane. They're generating that just to generate the hydrogen to serve the industry that requires the hydrogen. So really, in order to generate more hydrogen just for the aviation use, you need to really perfect that process of generating the hydrogen itself. And then you have to also talk about the distribution to every airport. And by the way, there can't be any leaks to all the tanks or things like that. And even for electric infrastructure for charging, so there's also another challenge there, because you will have a whole fleet of these airplanes. And so you have to have the kind of generation of clean energy at the airport or to the airport to support the whole fleet, as well as running the airport itself. So in the US, there's only one airport right now that's totally based on clean energy, and that's in Chattanooga, Tennessee. And so for that, they only have 2.6 megawatt. And we're talking about generating of tens of megawatts, or 200 megawatt, for example, in New Zealand. They're starting one project right there. So a lot of very challenging projects on infrastructure and also on the certification itself.
Add anything? So I guess I want to leave some time for Q&A. So one last question for you guys. What makes you optimistic about the future and that we can solve some of these problems?
Very optimistic, because right now we're already getting a glimpse of what's happening. Like the video I showed, it's already 6-passenger aircraft, which is hybrid electric. We can already do it, and it could be 100% emission-free, right? So we have our certification expected by 2024, and that's realistic certification. So I think the future is right here already. That's why I'm optimistic.
I'm really optimistic because of something I mentioned earlier. Just seeing companies be successful in raising money from investors, in basically creating a commercial market that puts a lot of focus on sustainability in the space segment. That's not something that's happened before, and it's just a lot of the hottest companies that are raising the most money that we see have that as part of their story. So I think it's makes me optimistic to see that and to see people building, successful businesses that will sustain these efforts, using the forces of capitalism, and make the environment cleaner and better for the future.
I'm really optimistic because I feel like all of society recognizes that climate change is our #1 threat to our society and to our planet. And as a result, step function quantum change is required and people investing in it. I'm also really thankful because we live in California, the cutting edge of all of those technologies, both from the infrastructure side, both from the green energy production side, as well as from investing in technology side. And I didn't talk about my actual background, but my background is actually working on the development of entry descent and landing systems to land on other planets. So if you want to know a difficult problem, that's a really difficult problem. So all the challenges that we're talking about here on the stage are infinitely easier than what the space program has to do regularly. So it's really just about changing our mindset of making the impossible, seemingly impossible, possible, and making those investments as taxpayers, as citizens in the way that you vote, as choices that you make in the consumer choices, in terms of what kind of car you're going to buy, in terms of, putting solar panels on your house. So I think all of the things that are afoot now in the, climate technology space are all doable, and they'll all happen if we want them to in well under a decade, to the extent that the technology does exist.
Excellent. Yes,
Hi, everybody. So we have a question from the audience on Hopin because we're also virtual. So the question is, I have seen some startups beginning to propose commercial cold fusion solutions for clean energy. How realistic are deployments of cold fusion technology at scale at this point? Is it even possible yet? And let me know if you need me to repeat it.
No.
So fusion is one of those things that people have been hyped up and excited about for a really long time, and so much so that it seems kind of mythological, but it is happening. And there have been some small successes in the lab, and I think that we're going to see it in spacecraft in the very near future.
Yeah, so I need to ask the AI question. Are any of you, your companies, using AI at all? And if you are, has it uncovered anything that surprised you that you wouldn't have uncovered without using AI?
Yeah, so our product is this simulation platform. So you can simulate everything that's happening inside of the spacecraft, and then multiple spacecraft kind of network together into a constellation, and we're doing it all in the cloud. So we're spreading it over hundreds, thousands of cores in the cloud, and so that lends itself well to AI applications or application of AI in larger kind of workflows. So we're using AI to enable our customers to tune their models of their spacecraft and their constellations over time. So when they start receiving data from the physical system, telemetry that tells them a temperature on a part in a spacecraft or a voltage or current, that's something that we're also simulating. And there's an extremely complicated connection between those low-level pieces of data that they have and what might be driving it. And so what do we have to tune in the model, pretty much? So we can continuously tune the model through testing and operations and help them identify maybe some possible failures before they actually happen.
We're not using AI, but I will say a partner located where we're located is, which benefits us in the sense that they do solar concentrator technology. So instead of having solar panels, you actually have mirrors that are actuated using AI to make the right selection during the day, and then it goes onto a plant which has a molten core that gets hot, and then that's then converted into electricity. So that allows them to be much more efficient than a traditional solar farm to generate solar energy, and they want to couple that to an electrolyzer to produce hydrogen in our area. So
our company currently no, But I just want to say something for the industry, as we just talked about those eVTOLs. A lot of those eVTOLs are pilotless, and so it would be autonomous flights, or same on the ground, when you have autonomous driving as well. So AI is extremely important, as we have seen, when Sebastian Thrun drove the Stanford Stanley the first time to take over from the Reds from the Carnegie Mellon University. That was mainly on the AI that won them the game.
Yeah, and broadly, with a lot of the portfolio companies who we work with, AI is everywhere. It is helping de-risk the engineering process and reduce iterations. It is helping people understand kind of employee workflow. It's helping to optimize operation of, both plants and final products, allowing autonomous flight. Some of the swarm technology that will ultimately lead to us being able to have aerial highways here in the cities, so that we can do, hopefully by the Olympics here, those flights between Santa Monica and downtown that were being worked on. And even things like pilot training, we're using integrated systems around AR, VR with AI to make all of that safer, as well as, of course, analyzing a lot of the data that we're getting from satellites. It's the transmission of data from space to Earth is limited and slow in many ways. So there's a lot that goes into both analyzing that data and compressing it and making it understandable and usable. So it's every part of aerospace. It's there. So.
And the Skynet, the satellites have more and more autonomy. It hasn't taken over yet. It's not scary yet, as far as I know. But there's a big focus on that, putting more autonomy on orbit. You need autonomy, and you designed entry, descent, and landing spacecraft, so you can't use a joystick to control things from that far away. So there are certain technical problems where they need the autonomy. You can't dock to spacecraft, to refuel in orbit, which is something that's happening now, without a significant amount of autonomy. And operating massive constellations with thousands of satellites and trying to, you can't have 1,000 operators on the ground. You need autonomy up there, so that's becoming more and more of a norm.
One thing I'll add, and this may be to a plug to anybody in the audience. So one of the things where AI would be really powerful for our area is predictive maintenance. And so that is already being exhausted by the military for predictive maintenance for a variety of different platforms. But it's something that we want to do, but we don't have a partner in it. So if any of you work at a company that is interested in helping in predictive maintenance for fuel cell technology, let us know, because we could potentially work with you.
Awesome. Any other questions? All right. Thanks, everyone. Thank you, guys.